and I'm going to continue to welcome you all to the Florida Friendly Landscaping Professional Webinar Series. Today's webinar is Turf Management to Protect the Environment with Dr. Alex Lindsey. This program is approved for 1 FNGLA, LIAF, DBPR, Landscape Architecture, and FDAC CEU. There is a $10 administration fee to receive a certificate of continuing education. I'll put that link in the chat box in just a few minutes. And you can follow that link to make payment for a certificate if you haven't already done so. We will be submitting the CEUs to the licensing agency in the next couple of days, and you should get your CEU by Friday at the very latest. It takes us just a couple of days to process those, and I always like to give people an extra day to sign up for the CEU. This is part of a monthly webinar series held on the second Tuesday of the month at 10 a.m. Next month's webinar is going to be Living Shorelines with Dr. Savannah Berry. And as you've probably noticed, your microphones have been muted. So please put your questions in the chat box. It seems like most of you know how to use that, so that's fantastic. We'll take the questions at the end of the presentation. And also, you'll see a survey invitation pop up. So please take a moment to fill that out. It really helps us determine what educational programs we're going to offer. And being that it's August now, Tom and I are going to be trying to put together next year's webinar agenda. So give us give us what you're interested in, and we will try to take that into account for next year's lineup. And with that, I'm going to turn this over to Tom Wickman to introduce today's speaker.
Thank you, Claire. I'm Tom Wickman, and I'm the Assistant Director of the Florida Friendly Landscaping Program and the statewide GIVMP Coordinator. And it's my pleasure to introduce our speaker this morning. It's Dr. A.J. Lindsey, and he's an assistant professor in the Department of Environmental Horticulture here at the University of Florida. He earned his bachelor's degree from the University of Wisconsin-La Crosse, his master's degree from the University of Hawaii in Manoa, and his PhD from Iowa State University. Upon completion of his PhD, he was a postdoctoral research associate at Iowa State University. His main research focuses on turfgrass performance, sustainable alternative management practices, and soil fertility and health. His extension program focuses on providing education, training, and assistance to the public and a diverse clientele. His program works with county extension faculty to provide education and product recommendations on turfgrass management systems that improve turfgrass quality while minimizing negative environmental impacts. With that, it's my pleasure to introduce Dr. A.J. Lindsey. He's going to be presenting turfgrass management to protect the environment. Dr. Lindsey, I'll turn it over to you.
All right, thanks a lot for that introduction, Tom. So like you said, I'm the newest member of the UF Turf team. I'm based in Gainesville. My specialty is going to be urban turfgrass management. And today I'm going to talk a little bit about turfgrass management to protect the environment. And kind of try to change how we kind of think of turfgrass management a little bit to kind of look at it more of a holistic approach to get where we kind of want to go in terms of turfgrass quality while kind of protecting the environment and minimizing the environmental impacts. So here's just a brief outline. So I'm just going to go into fertilization, BMPs, just briefly, kind of a new way to think about it. We'll go into soil health. What is soil health? Why do we care about soil health? Why is it becoming a bigger topic in the industry? And then we'll go into kind of some of the research that's ongoing about soil amendments and kind of how we can use these, incorporate these into our fertilizer programs or our turfgrass management programs. And then I'll go over to some of the research I'm doing, looking at some different fertilizer sources. And so this first slide is just looking at fertilization and nutrition BMPs. I got this slide from Dr. Unruh, but I think it's a good way to kind of change the approach of it's not just fertilizer in, turfgrass quality, and then the environmental impact. There's a whole system that's going on. And so we need to look at all the inputs and kind of factor that into our decision making. And so the goal of this BMP is to put the minimum necessary nutrients to achieve an acceptable quality and apply these nutrients in a manner or a time in the year that maximizes their plant uptake. So what we really want is we want to put in the minimum amount and get the maximum results. So get the biggest bang for our buck in terms of getting the quality that we need, but also limiting any potential losses to the environment. And so this is just a useful picture of thinking about, instead of just the fertilization and the turf grass, kind of think about what's in the soil and what are all the inputs that are going into this system, because we really care about this plant available nutrient pool. And so for inputs, you see on this left side, we have what we commonly think of as the biggest input, fertilization, but there's a bunch of other inputs. So some other inputs are reclaimed water. Sometimes there's nutrients in those waters. It's varied across the state. I know there's some new research coming out looking at reclaimed water and their impact on fertilizer usage and turf grass quality. Then there's a lot of atmospheric deposition of nutrients that also go into this nutrient available pool. And so the atmosphere itself, when it rains, it is actually putting some of those nutrients back into the system. And another one that we really haven't thought about too much, we kind of see it in the industry, you see it in neighborhoods, is just organic matter decomposition. So that means if you're in an older neighborhood, the soil has more organic matter, the microbes are going to start to break that down and release some of those nutrients, and that becomes plant available. And so I'm looking at some new research trying to factor in lawn age, organic matter, and how that kind of tailors into fertilizer recommendations. And the idea, the theory is that an older landscape or older lawn should be able to get away with less fertilizer inputs and still keep that quality that we all look for, because that soil itself is providing some of that nutrient. So it's not just all what we put in for fertilizers. But on the other end, this is a balancing act. So the soil can hold so much nutrients. So we have the inputs, whether that's organic matter breakdown, fertilization, but there's also outputs. So if you're removing clippings, that's removing some of the nutrients from this pool. So every time you remove those clippings, you're actually removing some of the nutrients from that system. There is gaseous losses. And so the microbes are kind of breaking stuff down, and some of these nutrients will get back lost into the atmosphere. There's conversion to unavailable forms. So whether those nutrients are binding to the soil itself, or the microbes are taking them in, and so the plant actually can't get to them that way either. And then the one that we kind of care about the most, or gets the most attention, is leaching and runoff loss. There's been quite a bit of research showing that, if it's a healthy turf grass, there's not going to be much for leaching. But this ultimately is one of the biggest concerns that we have. And so today I kind of want to think about how do we change this whole nutrient pool, this plant available pool that's in the soil. So how can we kind of improve the whole system to make this management a lot easier, potentially reduce fertilization, potentially reduce water inputs. It's really going to be based on kind of changing this whole turf grass system and not just looking at, fertilizer in, and then kind of what's the impact of that. Something that's really unique to Florida, that I've learned a lot since I started my job down here, is that there's a wide range of BMPs and recommendations within the state. So everyone's familiar with North, Central, South. Each of these regions have different recommendations, and then there's microclimates within each of these that also should have different recommendations. Coming from Iowa, it was pretty flat, and so we had this, one recommendation for a statewide. And so that's kind of one of the unique things with Florida, how there is these different zones and recommendations. And so we need to factor that in. We're also looking at our landscapes of, what is the actual microclimate, what zones we're in, and then we need to think about, just being stewardships for nutrients. So the right source, the right rate, the right time, and the right place of these nutrients and when we apply them. And so we need to look at that, but then within that, we also need to factor in kind of that whole turf grass system, that soil that's in there. And so there's a lot going on in terms of turf grass management and fertilizer BMPs within the state of Florida. So just touching on that and kind of thinking about this as a whole system, we'll go more into kind of the bulk of the story here, which is soil health or soil quality. So you can see here, this is kind of what a lot of us are dealing with nowadays. We're looking at these brand new landscapes, and they either bring in fill or they take away any topsoil. And so we're kind of left with this inert sand-based material, has low organic matter. So it's just going to provide a lot of challenges later on. And so we're kind of stuck with this system, and we're trying to figure out ways how can we change this whole turf grass environment just to make management easier or make it more sustainable. So here's just more of a close-up of what's actually going on in these construction. I got this slide from Dr. Evan Bean. But he kind of talks about how this landscape traffic or home building, you can see all this heavy equipment. And then you get these periods of wetting and drying in the environment. And what that does is when they use that equipment, when it's wet and dry, it's really good at vibrating it and compacting the soil. So essentially you're left with this inert material that's going to be compacted, and it's not really conducive for plant growth and especially turfgrass growth. But this is kind of what we're stuck with. This is the challenge that we're faced with. And so just looking at this, this new system, so they say it's a new development, it really has poor soil quality or poor soil health. And so the main things that we're looking at is, like I talked about, has that compaction. So that means it's going to be decreased rooting. We all know that turfgrass rooting is kind of the biggest thing of making your management easier. You have a really extensive root system. It's going to mine, different water, nutrients a lot more efficient from the soil. And so if we can really maximize that rooting, we'll really maximize the efficiency of this turfgrass system. These systems, since they are pretty much purely sand-based, they have low organic matter. So that presents challenges within itself, mainly in terms of water holding capacity and nutrient holding capacity. And so what this really means is we're left with this environment where we're likely going to have to increase our fertilizer and irrigation use to get an acceptable turfgrass quality. So it's not necessarily the most sustainable approach. And so now we're kind of trying to figure out what are things we can do to change this system, since a lot of times we can't change the whole environment, but can we do some minor changes to actually make management easier? And so there's a lot of products out there nowadays. There's a lot of big terms of, boosting soil health or soil quality, but there's a lot of different definitions of that. So the kind of the most basic definition I like to think about is it's the ability of a soil to function and sustain productivity, especially plant health. And so it's actually the soil's ability to provide, nutrients, air, water to these plants and actually provide a suitable location for them to grow. It has a lot of different secondary benefits. One right here, just enhance and maintain water and air quality. And so if you're boosting this whole the soil environment, it's going to make management easier, and it's going to be better for the environment, more sustainable. And so there's a few different principles and how to improve soil health. And so this is looking at, if you just Google soil health or how to improve soil health, the USDA has this chart over here. We'll kind of go step by step through how turfgrass fits into actually improving soil over time, and why turf is actually a good idea or a good plant to actually improve soil health. So if we look at this graph over here, there's 4 main principles of improving soil health according to the USDA. Turfgrass does 3 of these really well, and 1 we're kind of learning more about. So we'll start with kind of what it does well. So the first one they say is minimize disturbance. So a lot of these principles they're talking about are coming from cropping lands, but if we think about this in a turfgrass sense, minimizing disturbance, this is a perennial ground cover, and so this is going to minimize disturbance over time, and it's going to start to improve that soil health. The other one is maximize living roots, and turfgrass has a really extensive fibrous root system. So once again, turfgrass is really good at this principle, and it actually is going to start to improve the soil quality over time. And we find that, in older neighborhoods, that soil is actually a lot better than those current new developments. Another principle is maximizing soil cover. And so like I said before, this is a perennial ground cover. And so if you have a healthy turf strand, it's really maximized. It's covering all that soil. And so it does 3 of these principles really well. So the turf, in a sense, is actually building the soil. It's actually improving the soil over time just by itself. But what are some other ways we can actually, improve this even faster? Because a lot of times it takes years to actually improve that soil quality to actually, we can change our management. What are some things we can do to actually start that shift earlier? The last principle of soil health is maximizing biodiversity. This one we don't know as much about. It's kind of thought a lot of times since it's a monostand, biodiversity, we don't know. But if you look at this picture, a lot of times turfgrass is, in a landscape, and so there's a bunch of other plants around, landscape plants. So in general, this is a pretty diverse ecosystem in terms of, insects and everything like that. So now that we kind of go in about how turf grass is actually going to build the soil over time. Why is that even important? So why do we care about improving soil health? Why are companies trying to promote that? And it really comes down to, if we improve this soil, it's going to improve our the plant growth, the turf growth. It's going to make management easier, and it's doing that through a variety of different ways. So the first one we can think about is nutrient cycling and availability. So if we're improving that soil, it's just going to provide more nutrients to the plant itself. It's also going to improve the water holding capacity, so that soil is going to actually hold more water in it. You can decrease irrigation events. You can decrease the amount of irrigation. It's going to go through drought periods better just because it has more water to hold in that soil itself. And another one that we really care about is improving soil structure. So like I said, when we get these new developments, we get these new areas, it's normally highly compacted soil. So if we can start to improve the soil health, we can improve that soil structure. That means there's going to be more air exchange. There's more places for the roots to actually go down deep and effectively mine nutrients and water. And so if we can start to improve the soil, it's just going to make management easier. One of the challenges, though, with looking at soil health is that soil is very diverse and it's a very complex ecosystem. And so there's different ways to kind of measure soil health. So if you talk to a soil physicist, he'll give you a certain definition. If you talk to a soil chemist, he'll give you a different one. But realistically, we need to kind of think about all these in one. But some different physical parameters that people talk about when they're talking about soil health is the soil texture. This one's harder to change. You really have to put inputs into that soil to change the texture. But there's different ones like soil moisture, and I'll touch on that in a little bit, how different management tactics can actually help improve how much water that soil can hold. To look at porosity, compaction, some chemical parameters is kind of your organic matter, your pH, your CEC, just what are the nutrient concentrations within that soil. And then the last one is the biology of the soil. And so that's looking at microbial biomass, microbial activity, nutrient mineralization rates. So how efficient are those microbes actually turning over nutrients within that soil, making the plant available. And then just looking at soil respiration. A lot of times we find out that the physical and the chemical parameters that are measured, these are harder to change unless you're actually changing a big chunk of that soil. So say adding compost into the soil before you're putting turf on it, that really changes the physical structure of it. But if that turf grass is already there, these kind of changes take a lot more inputs and time to see these. Where this biological aspect, you can actually see changes quicker. So say over a 1 to 2 year period, you can start to notice some benefits in the biology, and then the rest of the parameters will start to fall behind. So if you can start to see changes in the soil biology, normally that the whole environment's going to change and be more conducive to turf grass growth. And so why we really care about this is that we're looking at soil health, and this really will improve our sustainability. So for improving the soil, you're adding organic matter, you're going to save money. You're going to save money on irrigation and fertilizer inputs. The soil is going to hold more water. It's going to turn over more nutrients, make nutrients plant available. And it's just going to make management easier. So any stress periods, if we're improving the soil, that turf grass is going to hold out better. It's going to perform better with those different stresses before we really see a downfall, before we need to put extra inputs into that system. And so that's kind of why we care about soil health or soil quality, and why it's kind of gaining buzz, why it's becoming a bigger deal in our environment, in our industry, and why there's a lot more products kind of pushing how to improve this soil health or soil quality. I'm going to touch on some of these. So these are the ones that kind of looking at today about improving the sustainability, or kind of what we can do to change this whole system to minimize some of our inputs, which will ultimately kind of protect the environment. The first one that's been used a long time in the golf industry is peat-based materials. So a lot of times they'll add peat into their sand mix just to give it a little bit of organic matter. This one's kind of being shifted away from, especially in landscape industry, just because peat's not a non-renewable resource. And so there's only so much peat. It takes a lot of time for that peat to develop. And so people are kind of going away from this one. There is a bigger interest in biochar. And I'm looking at more of that this year, but there's a lot of mixed results with biochar. So there's some positives, some negatives to it. And so it kind of depends on what are the goals ultimately. And so hopefully in the future, I'll have more kind of new research on biochar and what's going on with it. The next one is biosolids. So these are more used in the northern climates, just because they have more clay in their soil. So when you're adding biosolids, there's less chance of it actually leaching those nutrients out of the system, where biosolids down here might not be the best choice, just because you are adding not only organic matter, but you're adding a bunch of nutrients into this system. And so there might be some limitations there. But the main ones I'm going to talk about in terms of kind of changing the soil quality or soil environment is compost and then humic-based products. And then after that, I'll kind of touch on how we can use enhanced efficient fertilizers and then maybe some alternative fertilizers to really push the sustainability. So I think he's presented on here before, but Dr. Evan Bean has done a lot of cool research on compost and how we can use this in then urban environments. If you Google this, is actually a document he put together, kind of step by step, actually how you would do this in your landscape and how you would, incorporate this organic matter or compost into the system. And I'm just going to kind of go over some of his research results that he shared with me, just how we can kind of use this to improve our sustainability. So this is, like I said, research done by Dr. Evan Bean looking at compost. This is just one of his research study. He has a few going on, but this one's kind of the basis of it and kind of the biggest benefit that you get by adding compost into the system. So I'll walk you through what's going on. So we had 9 model homes. He left 3 as that compacted. So, that construction build. So it's just that compacted soil, just that sand-based compaction. He had 3 that he just tilled. He thought maybe if you just tilled it, you could alleviate that compaction and you might see some benefits just from that. And then he had 3 treatments that were tilled and then also used compost. So he tilled in compost. So he's adding organic matter, really building that soil structure again. The biggest thing he was concerned about was water holding capacity, or improving how much water is within that soil. And this can be measured by measuring the plant available water. And what that really is it's the difference between field capacity and wilting point. So field capacity is this top dash bar, and this is just how much water that soil can hold in general. Anything over that, the water will start to drain from the system. And so that's kind of the maximum water that that soil can hold. And then on the bottom dashed line here is the permanent wilting point. And this is where there's a lack of water to a point where the plant roots actually can't take the water from the soil particles. So it's bound so tight to the soil itself that the plant can't get it anymore. And so ultimately what he was trying to achieve was really increasing this plant available water within the system. And so we'll kind of walk through each of these treatments and kind of figure out what he found. So these blue bars is the field capacity. Is not so concerned about that. And then this red bar is that wilting point. You kind of see they're all pretty similar. What we really care about is this green bar, and that's that plant available water. So that's how much kind of water that soil can hold that is available to the plants itself. So if you look at just the straight compaction, it's really low. It's down here at 0.08, about that range. If you just till it alone, it looks like you get a minor increase, but it's not very significant. So instead of 0.08, it's 0.1. But if you add that compost, you're adding that organic matter. So you're improving the soil structure. You're adding that organic matter, which actually holds more water. You can see that it's over double if you do nothing. So what this indicates is that if you're going to till in compost, you can start to maybe potentially decrease the amount of irrigation that you need to put out there. He's doing some more research on kind of looking at what is that tipping point, how much water reduction you can save in terms of irrigation. But this is kind of the basis of, why would it be important to add compost to an environment? And so this is from his document. So it actually goes through step by step and whether or not he recommends adding compost or a different soil amendment. So he looks at bulk density. If you're above this, that means you have too much compaction. You should probably add compost. Then he looks at organic matter. So if you're below this threshold, a lot of times you'll see benefits if you add compost. And so a good quality compost really is effective at reducing soil compaction, increasing soil organic matter, which ultimately will increase how much water that soil can actually hold. And so he was looking at that in a tillage sense. So what are some other limitations of that is a lot of times we don't get to that landscape before it has turf on it. And so you might not be able to actually till in compost before you have to manage it. And so they did another research study. This was with Dr. AJ Reisinger, and they looked at top dressing with compost. And so you can see in these pictures, you know, half the lawn has the compost, it's the darker green. Compost has nutrients in it. And so you're seeing some of that effect here, but what are some of the effects on the soil itself, additionally to just the turf response? So if you look on the left here, this is the organic matter. And you can see on the bottom, this is one top dressing event, 2 and 3 top dressing events. The red bar is the before, and then the blue bar is the after. So after the top dressing, you can see that in all circumstances, with the top dressing of compost, you're starting to improve that organic matter within the soil. So that soil is going to hold more water potentially just from top dressing this compost. And so you might be able to achieve some of those benefits that we saw in the tilling just with top dressing. But one of the limitations, and something we need to factor in, and we're doing more research ongoing right now, is that there is quite a bit of nutrients within this compost. And so you can see it's the same graph, you know, the red bars before top dressing and the blue bars after. You can see that it's really increasing the soil phosphorus. And this can be a problem in some of our environments. Some of our soils are already really high in phosphorus, so we don't really typically recommend adding a lot of phosphorus into the system. And so this might be a limitation on compost. And so we're kind of looking more at that, and can we just adjust fertilizer recommendation rates, eliminate fertilizers in general if you are using compost. We just don't know enough about it, but we're doing some more research right now. But just briefly, just touch on compost limitations. It seems like the maximum benefits are from tilling. So you need to till it in to actually get those maximum benefits. And then there is you need to get quality compost, and then there's variation between products. And so we need to kind of factor that into the equation when you are picking a compost. And then, like I said, we don't know enough. We're learning more right now about kind of the nutrient impacts within this system. And so do we just need to adjust fertilizer rates? Or do we need to actually think about leaching, or is it just, you know, cutting back fertilizer or taking it away in general? So that's kind of the compost, and we see the biggest benefits appear to be, you know, more water holding capacity. We just don't know enough about the nutrient side of it. But that is one product that we're starting to see some great benefits in terms of that water holding and changing that soil structure itself. The next thing that I've done a lot of research on is humic products. And so there's some different benefits and claims that some, you know, manufacturers will say about these products. And I wanted to kind of test what is reality, kind of what are they just claiming? Is there some science behind this? But it seems like the main benefit comes in turfgrass rooting. This has been a few papers, and then I wanted to test this myself, which I'll get into. And then there's also benefits in terms of quality. Stress tolerance seems to be a big one. And then there's some claims saying that it's going to improve soil health or increase fertilizer effectiveness. And then, so these are some of the things that I was wanting to look at just to kind of verify, you know, what are these products actually doing. Just like compost, there is some issues or limitations with humic products, mainly in the sense that if they are adding a humic acid or a humic substance, that can really be broken down into a group of humic products. So there's fulvic acid, humans. So that's okay. You know, if it's X% fulvic acid, X% humic acid, that'd be okay. But within that, a humic acid isn't just one compound. So it's not like an herbicide that has one active ingredient. When they say humic acid, this is a whole range of compounds. And so that's kind of one of the limitations on each product is different in terms of how much of each fraction is in the product. But then within that, each of these could be different. And so you might see some good responses with one humic product, but not another product. And so that's something that we need to do within the industry, maybe is to actually kind of standardize what's are in these products so that you can compare product to product. Right now, it seems like you might get one benefit with one, but it might not be the same with every product. And so that's something that we're kind of working on and we need to do a better job on. But I'll kind of go over how we can incorporate these humic products into, you know, changing that turfgrass environment, making it more sustainable. And just another option, kind of like compost is an option to improve organic matter. These humic products seem to be doing a few different things within the turfgrass system that should improve the sustainability, or could be used in a management practice to kind of help limit some of the inputs while we're protecting the environment. So the first one is I just want to confirm the rooting response that I saw in the literature. Some of these were done hydroponically, so I want to do it in an actual soil system. And so these are rooting tubes that have an inside liner that's filled with sand, and so you can actually track rooting along the way while these plants are growing. And then at the end of it, you can actually measure the rooting and see, is there difference between products? And so here is just a picture of this, just to get a visual, just kind of what it looks like towards the end of the trial. So this top 3 products all have humic in them. And so anytime you see an H from here on out, that'll stand that it had humic added to this. So this is just a synthetic fertilizer with humic product added to it. This is a poly-coated humic coated urea, so another humic product. This next one is urea with a humic added to it, and then a starter fertilizer which has phosphorus in it plus humic, and then a starter fertilizer without, and then we have just our nitrogen sources down here, so a U-flex, urea, and then just non-treated. And so the first thing you'll notice is that these 2 starter fertilizers really improved rooting. That's due to it has phosphorus. So anytime at establishment, we know there's a lot of studies out there that phosphorus is one of the main things that really push rooting. The root system isn't extensive enough to typically find the phosphorus that's in the soil, and sometimes so you'll get a benefit in establishment if you add phosphorus. So it's kind of nice that we picked that out and kind of confirmed what the literature is saying, kind of confirm what we're taught in terms of management. And then adding that humic to it, it seems like that phosphorus is kind of the ultimate factor in terms of increasing rooting at establishment. But if we take away those 2 treatments that have phosphorus, and we just look at these top 3 treatments that are nitrogen alone with a humic product, and then just nitrogen alone, is there any differences between those 2? And so if you look at these first 3 products, you're starting to notice that there actually is increasing in this turfgrass rooting, mainly in how wide and dense this turf rooting is towards this middle section here. It appears about the turf length or turf root length is about the same, but it's starting to improve that branching, or it's making it more fibrous. And so what we can do is we can actually scan these roots and then run them through a software, and this will actually count all the different root hairs, the root branching, and see if we're really improving that root architecture. And so that's what I'll present here. So once again, this is looking at just that total rooting, so all the root hairs, the root branching, and it just is going to calculate all up so we actually get a number and can compare these treatments more effectively. Once again, these 2 bars in the middle are the treatments that had phosphorus. So phosphorus at establishment is kind of the key pusher in terms of turfgrass development and rooting. But if we take those out, we can start to see that difference that picture was indicating. So these products on the left here, so synthetic fertilizer with humic, this poly-coated humic coated urea, and then urea with this humic product added to it, are really starting to improve or increase that rooting. So it's improving that root architecture. It's going to make the system handle stress better. It's going to mine nutrients better. It's going to mine water better. And so this is really going to start to improve that turfgrass rooting, which ultimately should make management easier down the road. So that's kind of step 1 of what these humic products are doing. They're starting to increase turfgrass rooting within this system. Excuse me. The next thing that we looked at was, what is the actual soil health response? Are we starting to see some soil changes with these products, or is it just a turfgrass response? And so the first thing I looked at was soil microbial biomass. There's a lot of correlations where if you're increasing the biomass, you're improving the soil in terms of nutrient cycling. So that soil itself is going to be more efficient at turning over any nutrients that are held up in that soil. It's going to decompose that organic matter better, which once again is going to release nutrients. And then lastly, it's going to start to improve that soil structure. And so I did all this soil work looking at 2 different systems. So this was some of my research that was done in Iowa. And so the first one was a native soil. So a native Iowa soil is rich in organic matter. It's a heavier soil, has a lot of clay. And so we didn't really expect to see much for differences in terms of biomass. It's already a healthy soil. And so if we just look at these products here, they're all about the same. So it didn't really increase the microbial biomass in this native soil. However, I also did this in a sand-based system. So this is on a putting green, but it should translate over to any sand-based system. So this is kind of what we're dealing with a lot in Florida here. And so this is a variety of different products. So humic coated urea with another humic added to it. And the same thing here, just a different humic product added to it. Urea, the humic alone, and then a non-treated. And so the blue bar is year 1. And then the year 2 is this orange bar. So year 1, we didn't really see a whole lot of changes. But year 2, we saw some great improvements. So it seems like if you really want to start to change the soil, you need to commit to a humic product and actually apply it to the same areas over time to see any of these soil health benefits. But we can see that these 2 products that we added this extra humic to it really is to improve that soil microbial biomass compared to all the rest of the treatments. So we're really starting to improve the soil biology with these products. And so that's great. So we're improving soil biology, but are we actually improving how active that soil is? And so another measurement I did was looking at potentially mineralized carbon. Essentially, this is measuring CO2 fluxes over an incubation period. And so you take out a known amount of air from the soil incubation, you put it into a device that measures the CO2. And this has been correlated in a lot of cropping systems in terms of how much nitrogen will be available within that system. So they found within corn, if this number is higher, it's going to have a more active soil, and they can actually get away with less nitrogen inputs and achieve the same amount of yields. And so I think that should translate over into turfgrass, where if it's more active, we could put in less fertilizer and still get the same quality. The other thing I measured in terms of soil activity is nitrogen mineralization. So this is how much plant available nitrogen the microbes are turning over in that soil. So a higher number here might indicate that we can start to reduce the amount of fertilizer inputs. And so this is just looking at my microbial activity. So that general CO2 response, is it increasing or not? And this is looking at the synthetic fertilizer with added humic and this polycoated humic coated urea. And you can see that it's starting to really increase the actual microbial activity within that soil compared to just nitrogen alone. And so it appears that we're not only increasing the biomass, but we're also improving the activity, or making the soil more efficient at potentially turning over nutrients. This next one is actually just measuring that turnover of nutrients, so how much nitrogen that soil is actually providing to the plant itself. And we can see that this one treatment here really jumped out. So this is a humic coated urea with an added humic product to it, just to really boost that humic input to see if we can achieve the maximum benefits. And it's really starting to improve this nitrogen, or how much nitrogen is getting turned over in that soil. So it's going to improve nitrogen cycling and nitrogen efficiency. And so to kind of summarize what's going on with these humic products and how they're starting to change the system, is it's really increasing that rooting, especially if we can apply phosphorus. It's going to really boost that turfgrass rooting. And then it's starting to improve the soil health, especially the biology of that soil. So it's going to start to turn over nutrients more efficiently. But ultimately, what I wanted to get at with this research project was, can we decrease nitrogen inputs and still achieve the turfgrass quality that we were looking at in terms of, you know, a standardizer, the normal nitrogen recommendations. So within each of these, so the native soil and the sand base, I incorporated these reduced rates of nitrogen. So this one is 3/4 the normal rate. So we're cutting out 1/4 of the yearly nitrogen all the way down to half. So we're cutting out half of the nitrogen, and then just see what happens in terms of turfgrass quality. The same thing happened in the sand-based system. I cut out 1/3 of the nitrogen and kind of see where that, could it hold on to that quality. I didn't try to go any lower just because it was on a putting green. And so I didn't know if we could get away with a lower rate than that. So here's just a graph looking at visual quality. So this first one is that native soil. That 6 is kind of what we deem as acceptable in the turfgrass industry. So anything above that's acceptable. The first thing you'll notice is that there's 2 different kind of distinct bands. So this top one that has all these colors, and this bottom one that has the black and the gray. And so this black and the gray are the 2 treatments that didn't have any nitrogen. So the humic product alone, and then the non-treated. So we kind of expected that that quality should be lower since there is no nitrogen in that system. But the important part to kind of pick out here is that these reduced rates, so this red bar, this orange bar, and this yellow bar, these are the reduced rates. So we're cutting out a quarter of the nitrogen all the way down to a half of the nitrogen compared to these full rates, and we're still getting the same quality. So it's indicating that we really might be able to reduce nitrogen inputs and kind of maintain quality over time with adding a humic product into the system. And so we jump over to the sand-based system just to see if, does it translate between, a nice, good quality Iowa soil compared to just a sand system. And once again, we'll see these two distinct bands. So this top band, once again, is any treatment that had nitrogen. This bottom two are the two treatments that didn't have nitrogen. So that's the non-treating the humic alone. So once again, a humic product alone isn't going to boost your quality. So we really need to add some nitrogen into the system to get that turfgrass quality. Once again, if you look at this red bar, this is the one that we cut out a third of the nitrogen for the yearly inputs, and it still maintained turfgrass quality compared to these full rates. So once again, in the native soil and in the sand-based system, it appears that we can cut out some of the nitrogen with these humic products and still maintain quality. You do notice that this red bar is kind of on the lower end of these ratings. So it's in the same grouping, but we might get in close to that tipping point. So in a sand-based system, we might not be able to get away all the way down to a half rate, but I'm going to do future research right now, looking at kind of where is that tipping point and does that translate down here in Florida directly too. So to kind of summarize these humic products, it looks like we might be able to get away with less nitrogen inputs when we're adding humic into the system. That's likely due because we're enhancing that rooting and we're increasing that soil health. We're changing that soil biology. So the enhanced rooting is more effective at getting those nutrients, and then we're increasing the soil biology so that the soil is actually going to turn over any nutrients in that soil more efficiently. And so here's just a picture of this next trial location where I'll be doing similar studies here in Florida. One's on the St. Augustine grass and one's on the zoysia grass. And then to kind of wrap up, so we're adding different soil amendments. We're looking at compost, we looked at humic products and how those can be incorporated to either improve water holding capacity, potentially decrease nitrogen. The last thing we can do just in terms of sustainability or protecting the environment is using the right types of fertilizers. And so there's a bigger push on using enhanced efficiency fertilizers, and to be classified as what I'll term as an EEF, you need to improve the nutrient use efficiency, and you have to decrease the potential losses to the environment. You need to do both of those to be classified as EEF. And typically these are done by just different coatings on the fertilizer itself. So think of a poly-coated urea. It's going to release that nitrogen slowly over time. But there is some different products that are trying to get this kind of classification. One of the limitations is a lot of times they classify these done off of just lab testing. So this isn't really always in the real world or in the environment. And so I went ahead and I kind of developed a system to track this and see if these fertilizers could be classified that in a real world scenario. So the first one is looking at step one, so improving that nutrient use efficiency. And what you do for that is you use these ion resin strips. And so you bury these in the ground, you replace them over time, and these little strips act as like a super sink. And so any ion that comes close to it, it will attach to it, and then you can extract those later off. And you can actually calculate how much plant available nitrogen was within that system based on which fertilizer you used. And so this is a graph looking at that. So this is total inorganic nitrogen or plant available nitrogen throughout a growing season. And you can see that there's one treatment that kind of jumped off compared to the rest of them. So they're all right around 20 to 25, and this one's above 30. And so this is this poly-coated humic coated urea. So there's something about this treatment that's actually improving how much plant available nitrogen was within that turfgrass soil throughout the growing season. So this treatment kind of fits that step one. It's really improving the nutrient use efficiency. Step two is actually tracking potential losses to the environment. So a lot of times they use a lab-based test. They put this fertilizer in the water, and they calculate how much nitrogen is released after so many days. But I wanted to go kind of in a real world scenario and factor in, soil temperature, soil conditions, and how that actually affects the nitrogen release. And so I use these mesh bags where you actually put a known amount of fertilizer in this mesh bag, use a cup cutter, then you bury it at a certain depth, and you collect these over time, and you can actually calculate how much nitrogen is being released over time. I just like to show this picture. You can kind of see these are the distinct lines where those mesh bags were buried. So you can see that nitrogen that's within that system is really contained when that turf grass is growing. It's not really bleeding over. It's just kind of right where we put that fertilizer. So this is just an important picture to really think about where we're putting the fertilizer, and if the turf is growing and it's active, it's really going to assimilate those nutrients. But this will get back to the mesh bag part of it and look at this nitrogen release curve over time. So if we look at the y-axis, this is how much nitrogen is released from that fertilizer. And then down here is how many days after. So how many days was that fertilizer buried? And so you can see there's kind of 3 distinct lines. This top one is a known commercial product. It's XCU, so it's a polycoated, sulfur-coated urea. And each year it had the same release curve. And so by about 50 days, it's kind of released all its nitrogen. And then there's other 2, so the green and the blue are actually this polycoated, humic-coated urea, which is a newer product coming out. But you can see it has 2 different kind of release curves. And at first, I didn't really understand why that would be until I started looking at the environmental conditions. And so this green bar was in year 1. We had a big drought at the start of the year. And so it actually coincided with this product not really releasing a lot of nutrients. So that was kind of beneficial because the turf wasn't growing well. And so this actually wasn't over providing nutrients at that time. Year 2, we had a wet spring, and you can see it was releasing nutrients over time. It's releasing more of those nutrients early on. And so this product could be interesting. And I'm looking at it now just to see if this is a trend that kind of holds true, where this kind of releases nutrients based on when the plant could actually use them. And so this might be a really interesting product in terms of sustainability. And so it looks like this polycoated, humic-coated urea, which is a newer product, fits that definition of enhanced efficiency fertilizer. From that previous one with the ion strips, it was increasing the plant available nitrogen. And then this, we can see that it's releasing it slowly over time. And then just to wrap up real quick, I think I got a few minutes left. I'm just go over some alternative fertilizer sources and how we can start to use this within turfgrass management to really cut down on maybe the synthetics that we use, or just use a byproduct in a different way. So the first one is an algae-based fertilizer. So I worked with a company in Iowa. You can see these belts here, and they'll attach algae to these belts, and they'll go in and out of wastewater. And so this algae is actually effectively cleaning wastewater, taking those nutrients out of the wastewater before it's discharged. But then they didn't know what to do with the algae. And so I started working with this company, and we decided it might work as a turfgrass fertilizer, since there is a product similar out there. Milorganite is also based off wastewater treatment. And so we kind of wanted to see, could this algae actually be used, or is it too much high in salts or anything else like that where it might minimize turfgrass growth? So here's just a slide of, kind of this nice sustainable closed loop circle that would be developed. They'd use their thing to clean wastewater. That wastewater could be discharged, and then we could use that product to fertilize. So essentially, we'd be making a sustainable fertilizer source. And so the first thing that we did was look at it in the greenhouse, just to see if it could release those nutrients, or if there was something wrong with the product where it couldn't effectively release them, or the turf grass couldn't take them up. And so we looked at a greenhouse study. And so from left to right, we have just the pure algae. So they scraped the algae, dried it down, made it into a pellet, and we applied it. And then they used the blended, so it's algae plus a cellulosic filler. This was to kind of reduce how dusty it gets. If anybody's using Milorganite, it can get kind of dusty and get fine particles. And so that was kind of used to kind of bind the pellet together. Then we compared it to Milorganite, and then compared it to urea and a non-treated. So you can see that these two algae products performed about the same as Milorganite, which was kind of the ultimate goal. Since we were in the greenhouse, we could also look at rooting. And so once again, this product was about the same as Milorganite. So as in terms of top above ground growth and below ground growth, it's performing the same as Milorganite. And that's kind of what they wanted to achieve. And so from there, we want to take it a step further, and can we see this results in the field? And so these are just some trials. So I did it on both cool season and warm season grasses just to kind of confirm. And this is just showing that these dark green dots were actually the algae product. And so it's actually releasing the nutrients about a week ahead of Milorganite. So Milorganite sometimes can take about 2 weeks to really kick in. This one only took about 7 to 10 days. So here's just a close-up picture. And you can see that the Milorganite and this blended pellet have about the same turfgrass quality, and then there's just the non-treated as a reference. And so it appears that this algae might be a good sustainable fertilizer source, and I'm trying to work with them to develop it and make sure, can we potentially clean some waterways down here in Florida and then use that algae as a fertilizer source also. And then the last one that I'll touch on real briefly is just a plant-based fertilizer. This is a byproduct from a wet milling process. So they mill corn, potatoes, peas, and then they have a byproduct. It's a liquid fertilizer. They didn't really know what to do with it, and so I thought maybe we could use it as a turfgrass fertilizer since it does have nutrients in it. And so here we just took it to the greenhouse again, and this is vegetable protein A, B, and C. It's a proprietary blend, so they won't tell me exactly what was in it. And then we just looked at a non-treated urea. You can see from this above ground picture that it's really boosting that turfgrass growth. And if we look at the rooting, you can see some of these scans, you can really see how it's improving that rooting. And that's likely because these are complete fertilizers that has N, P, and K. And so that phosphorus is in there and it's really pushing that growth, that development. But once again, it appears that it's effective at releasing nutrients. And so we might be able to use a byproduct as a fertilizer source, really improving our sustainability in the future. And so this slide just kind of summarizes those, the algae-based product and the plant-based product that might be a really good, effective, sustainable, natural organic product. But we don't know if there's any soil health benefits also to this. And so I have ongoing research kind of looking at that aspect of it. So just to kind of sum up, the main kind of takeaways is that we're trying to change this whole turfgrass system, whether that's the turf itself, so like a humic product, you're improving that rooting, or changing the soil itself. So compost and the humic products, they're adding organic matter, they're changing that soil biology. And so we might be able to get away with less irrigation, less fertilizer use. And we have more ongoing research to kind of see or quantify that better. But it appears that with compost, you can get away with less irrigation, potentially less fertilizer. With these humic products, it's increasing that rooting and the soil health. So it looks like we can get away with less nitrogen inputs and achieving that same quality. And then it appears that there is becoming a bigger market for companies to try to create or use their byproducts as a fertilizer source, so that we can really start to get away from maybe some of those synthetic fertilizers that we use. And so with that, I'd like to open up with any questions. There's my contact information if you ever need to email me. Always feel free to reach out. I'm always happy to help in any way I can.
Hey, Jay, thank you so very much. Wow, you covered a lot, and my head's kind of spinning a little bit, but I'll go ahead and read to you a few questions that some of the viewers had. Number one, can you talk a little bit more, define humic, and then talk a little bit more about some of the humic products?
Yeah, I'll just jump back to that slide because it's easier to talk about it. So humic products, a lot of times, they might say it's just humic acid, or they might say it's humic and fulvic acid. They might say there's humin in there. But if it just says humic substances, odds are it's going to be a combination of the three. And so it's going to be a fulvic acid, which is normally a smaller molecule, so it's more easily to move throughout the soil or more used by plants. There's humic substances where it's kind of a medium size molecule, and so they break down at a decent rate. And then there's humans, which are really complex kind of molecules, and so these take a long time to break down the environment. And so that's kind of what could be in a humic product. But in terms of each humic product, they have different ratios of humic acid, typically is what they're reporting. And so some products have 2% humic acid, and they are treated more like a biostimulant. And then they have some products that are 70% humic acid, and they're trying to look at it as more of a soil amendment. And so there's a lot of variation between the products, and they don't have a lot of regulation on it right now. And so it's really hard to compare product to product. And that's kind of one of the challenges that we're faced right now. So I hope that answered the question. If not,
Certainly
I can
did.
always...
That's awesome. That was a big help. Do we need a soil sample in order to apply phosphorus?
Yes, you should have a soil sample. The only time you might not need one is if it's just that establishment to put a little bit out there just until that root system kind of gets developed. But besides that, we kind of say that you should get a soil test for phosphorus, especially in a lot of these landscapes. Typically, we don't recommend adding a whole lot of phosphorus.
All right. When you mention phosphorus as the optimal rooting nutrient, does the application include nitrogen, such as DAP, or strictly phosphorus only?
So in terms of this study is what you're referencing. It was a nitrogen and phosphorus within that starter fertilizer. A lot of times it's recommended at establishment, you can put out a little bit of phosphorus just to really boost that turfgrass development. And so that's why we included it here, just to really see that effect. And so in terms of establishment, it does seem like adding phosphorus where that turfgrass roots can actually find it does seem beneficial. But it does appear that these humic products, so it's just nitrogen, then a humic product added to it, will also start to increase that turfgrass rooting, especially in circumstances where, we don't recommend putting phosphorus out.
Great. Is humic acid considered a fertilizer?
No, it's considered a soil amendment or a biostimulant. It depends on kind of the ratio of it.
All right. Would you recommend using more humic products if you're not able to use phosphorus-based fertilizers to improve root mass?
Yeah, I think so. I think typically, especially if you're in an environment like a new development where turfgrass rooting is a little bit tougher in general, I would say you might see some bigger benefits with adding a humic product into your management practices. If you're at a more established landscape, you might not see as much benefits because there is some organic matter in that soil already. So you might not see quite the effects of like a new development.
Terrific. Are there ways to get the alternative fertilizers, that you're studying, highlighted more?
I've been doing more research with them. I'm trying to work with the companies to get them more real world data. The greenhouse studies are great, just in terms of showing that the product could work, but they need more kind of research to verify the product before they can really seem to market them. So that's kind of the challenge in terms of a lot of these companies have a product, but you need to do X amount of research to actually show that it's a beneficial product to use. And so in terms of highlighting it more, I think it's just going to come out more in the future as we just work with them more often.
Question, where does humic come from?
Humic there's a lot of different sources. One of the main ones they use for these products in turfgrass is leordarnite, I think is how they pronounce it. And they actually ore it. So it's found within the environment, and they actually will go ore it and then they'll mill it and kind of get it into the product they want. But there is different humic products that are from peat, they're from compost. So there is a variety of different products, but the main one is it's a product that they normally mine.
Okay. This one may be tough. Please compare the cost of the humic products, the enhanced fertilizers, and compost plus traditional fertilizer.
Yeah, that one.
That one's a lot to throw at you.
Yeah, I know. So I don't have the best indication on compost cost. Dr. Bean would probably know more about that. He's worked with that more than I have. In terms of the enhanced efficiency fertilizer and the humic products, that is kind of one of their limitations where, it is extra money compared to just a straight, synthetic fertilizer at this current moment. But I don't have a good direct cost. They all kind of cost different money, so I don't know for sure.
All right, that's kind of where I thought we were gonna be at this stage. It's still early. So much research going on. Are any of these Humic products available, currently on the market, like from the big box stores?
The big box stores, I'm not sure. I know most of, the commercial landscape companies or the turfgrass companies, they all have Humic products nowadays, but I'm not sure about the big box stores. I'd have to go check.
Okay, a lot of comments about people liking this, the direction you're going, and all the new research that you're bringing up. So pretty excited to see where it goes as well. Have any studies been done if there's an increase in nematode activity in regards to compost as a top dressing, even if sterilized?
I don't know about that one. No, I think that would be a better question for Dr. Reisinger or Dr. Crow. Dr. Crow does the nematode stuff. I know a lot of these products that are changing the soil biology or improving the soil biology have seen some decreases in diseases, but I'm not so sure about nematodes. So I can't answer on.
All right. Is there going to be a long-term study on nitrogen decreasing nitrogen rates in combination with soil amendments? Would there be any concern that decreased inputs long-term may show declining results in established soil over time?
Yep. So that's something I'm trying to start up right now in the longer term, because we saw some benefits over 2 years and we can get away with less nitrogen over 2 years. But that was another concern that someone brought up, that maybe we're getting away with it in the short term, but we might not see that forever. If that soil is providing some of those nutrients early on, it might get depleted. So I am currently trying to develop and get a longer term study started.
Okay, interesting question. A lot of cities and counties in Florida ban fertilizers, during the rainy seasons. We've got lots of different ordinances around the state. Is humic acid harmful to waterways in any way?
That I do not know about. I can't really answer on that. If I had to speculate, I would guess that it's not too harmful, because they are it's organic matter essentially, but it doesn't have nitrogen or phosphorus in it, so I don't know how harmful it would be. But I can't say for sure. That's not my expertise, I guess.
All right. This may not be something you can answer. It may be something for Dr. Bean. How do you know if a compost product is of good quality?
I know I've talked to him before, and he recommends getting one that's certified. So there is an organization that will certify the compost. Generally, if it has that certification, I think it'd probably be okay to use. But in terms of the exact specifications, in terms of pH and everything else, I think Dr. Bean's trying to develop general recommendations. So I think he'd be the best one to contact.
All right. Hey, Jay, we've got most of the questions. Actually, I just saw a couple come in. Can you talk a little bit more about biochar? Describe biochar a little bit.
So biochars typically, there's a few challenges with biochar. Sometimes the results are based off the feedstock, and so essentially they put it in a feedstock and then they heat it up to a certain degree where you're kind of just left with what you think of, like charcoal. Essentially is what it becomes. So there has been some research, but it's been kind of up or down. I know there's some research on herbicide usage. And so if you're using biochar, sometimes herbicides aren't as effective. But in terms of adding it into like a soil amendment, I think that's kind of where the research is lacking. And that's kind of what I'm trying to get a study going to look at that more directly, because I know it's becoming a bigger topic.
Okay. Well, I can't say enough thanks for giving this presentation, sharing your research. Looks like we've got a lot to learn. We're learning a lot, but certainly have a lot more to learn, and we look forward to having you back and giving us updates on where your research has gone. I'm pretty excited, by the way, for our audience. Again, next month we've got our next webinar scheduled for September 13. It's on living shores with Dr. Savannah Berry. Again, that's the second Tuesday at 10 o'clock. And make sure you do fill out the survey if possible, just as Claire mentioned early on. We want to make sure that we get your feedback on what presentations and what topics you'd like for the coming year. Dr. Lindsey, thank you so much again, and I look forward to working with you and having you back.
All right, thanks a lot.
All right. Take care, everybody. Have a great day.